Hello guys, today we're going to go over 2.3. Now 2.3 focuses on synthetic division, long division, dividing polynomials by different degrees. I'm not going to go over those portions because we went over that last year, so you should be able to remember long division and synthetic division. And throughout this entire process now you can choose however you want to divide. But the two things we will see that are new are example 5 and example 6. And we kind of saw example 6 last year. But let's begin with example 6 actually. It's the factor theorem. All the factor theorem states is that if you divide a polynomial by another polynomial and the remainder is 0, then that means that what you divide by is a factor of the larger polynomial. So for example, they say 4x4 plus 21x3. This is the example 6 in the book, by the way. Plus 25x2 minus 5x plus 3. And they ask you, please determine if this is a factor, and please determine if this is a factor. Now, if you do synthetic or long division, because you can do both of these factors, or possible factors, you'll see that when you do the x minus 1, you're going to end up with a remainder of 48. And when you do x plus 3, you're going to end with the remainder of 0. What that means is that this is a factor of this polynomial. This is not a factor of this polynomial because you got a non-zero remainder. So that was the easy portion. And again, the following portion is also pretty easy because again, all you got to do is divide synthetically or long division, but it's quite interesting. And this is one of those mathematical oddities that I did not know existed, but it's quite interesting. And it's the remainder theorem. Let's say they give you that particular word problem and they give you the following numbers: x minus 3 minus 12x squared plus 48x plus 74. Now, I'm going to do this one entirely via synthetic division, okay? Because I want you guys to just refresh the process. And there is one change between the remainder theorem and the factor theorem. In the factor theorem, you just divide via normal division, synthetic or long. So if they ask you to divide this synthetically, remember, we changed the sign. We turned that into a 3. If they give you x plus 6, we changed the sign and use this to divide. However, when we're doing the remainder theorem, you do not change the signs, and you always do synthetic division here because they're going to give you a value. They're going to say evaluate this polynomial. For example, when x equals 12, which is the example in the book. Evaluate this polynomial when x equals 12. Now, previously, you had to do 12 cubed minus 12 times 12 squared plus 48 times 12 plus 74. Basically, substitute your 12 in each x, properly distribute or expand or distribute the exponents, multiply, combine like terms. Without a calculator, it's pretty uncomfortable. But now there's an easier way to evaluate this polynomial for 12. All you do is you do synthetic division, but you do not change the sign of the number they're asking you to plug in. If they're asking me to substitute a 12, I'm going to do a synthetic division using the number 12. And let's begin. This would be a 1. There are no missing degrees, so all I have to do is put the actual numbers. And remember, 1 plus 0 is 1. Now I multiply, positive 12. Now I add 0. Now I multiply, 0. Now I add 48. Now I multiply, 576. And when you add, the remainder is 650. And this is called the remainder theorem because that remainder will be the answer of this polynomial when you plug in x equals 12. So instead of doing 12 cubed minus 12 times 12x squared, or 12 squared plus 48 times 12. So instead of doing all those, operations and joining like terms and increasing things to varying degrees, you do the remainder theorem. Put the number you have to plug into your polynomial, do synthetic division. The answer will be the end result of plugging that number in here. Now notice how quickly you can do a synthetic division versus plugging in a 12, raising it, cubing a 12, squaring a 12, multiplying it, joining like terms. This is way easier and way simpler. And that is the remainder theorem. That's today's class. Again, if you don't remember long division or synthetic division, make sure you ask in tomorrow's class. Have a great day.